Alright, so I did this question in the video earlier, and I made a mistake, right? And I don't want you to get confused, so I'm just gonna do it again, and I'm gonna cut out that part of the video so you don't see it. So you're only gonna see this part of the video. So the time right now is 10 p.m., but the second of the video, the time will probably be like 8 p.m. because I did the second half of the video correctly. So basically, this video is gonna be no mistakes. Anyways, I'm just gonna do a bit of moles with you, okay? So let's say I know that you know the basic moles are N equals mass over mR and how to work out relative formula mass. It's just what confuses you is the ratios and stuff. Anyways, just read this question here. If 1 gram of methane is burnt completely in oxygen, so that's complete combustion of methane, what is the maximum theoretical mass of water that can be produced? So this is a mixture of a combustion and moles calculating masses question. CH4, that's methane. I'm sure you know that. I'm sure you've been taught that. And when things are burnt, they're burning oxygen. In the exam, you'll probably get the equation. It's just in A level, we have to do it ourselves. So we have to write it ourselves. But I'm pretty sure in GCSE, you will get this equation. You'll just have to balance it yourself. So let me just quickly write this up. Methane, it reacts with oxygen and it produces, carbon dioxide and water. Because when anything burns in combustion, the products are carbon dioxide and water. Okay, right now this is not balanced. First thing we need to do to balance is look at the hydrogens. There's 4 hydrogens here, there's 2 here, which means we need to put a 2 here to balance. So there's 4 hydrogens here, 4 hydrogens here. There's 1 carbon here, and there's already 1 carbon here, so that's okay. Now there's 2 oxygens, because there's 2 here, 1, so 2 times 1 is 2. And there's 2 oxygens here, so that's 4 oxygens on the right side, which means there needs to be 4 oxygens on the left side. There's already 2 oxygens here, so to balance it, we put 2. So now that is completely balanced. Okay, now we need to read the question. What can we get from the question? We've got 1 gram of methane. Now, we've got the gram, and we've got the formula methane, right? CH4. So we've got we can work out the MR, right? Because moles equals mass. We can work out the moles, sorry. We can work out the moles because moles equals mass over mR. We're given the mass in the question, 1. And make sure it's in grams, because they might trick you and give you like kilograms or milligrams. You always need to make sure it's in grams. So that's 1. And the MR of CH4 is... Okay, so the MR of carbon is 12. The MR of hydrogen is 1. We've got 4 hydrogens, so we do 1 times 4, which is 4, plus the 12, which is 16. So 1 over 16, and the answer to that is 0.0625. So we have 0.0625 moles of methane. Now, the question is asking us what mass of water is produced. Now, for this, we need to look at the ratio. Now, essentially, there's an invisible 1 here, and there's an invisible 1 here as well. Now, we're only going to be looking at this and this. So the ratio is 1 to 2, because there's a 1 here and there's a 2 here. If it was 1 to 3, it'd be a 1 to 3 ratio. If there's a 1 here and there's a 4 here, it'd be a 1 to 4 ratio. If there was a 4 here and there was a 2 here, it would be a 4 to 2 ratio. But this time there's a 1 and a 2. So right now in this situation, there's a 1. In this equation, there's a 1 to 2 ratio. Let me make that 2 a bit more clearer. There. So what that means is if there's 0.0625 moles on this side, since it's a 1 to 2 ratio, there'll be double the moles here. So the moles of H2O, so NH2O, N means moles by the way, is 0.0625 times 2, which I think is 0.125, 0.0625 times 2. Let me just put in my calculator is 1/8, which is 0.125 mole. So what we've essentially worked out is we've worked out the amount of moles of hydrogen we have. I mean, water we have. Now we want to work out the mass. Now, if we rearrange the equation, moles equals mass over mR, we can get that moles times mR equals mass. Now, we have the moles of the water right here. So 0.125 times the mR of water. Now, mR of water, so there's 2 hydrogens, so that's 1 times 2, which is 2. And oxygen has a mR of 16. 16 plus 2 is 18. So 18. And the answer to this is 2.25 grams. And that's the answer. That is the maximum amount of water that can be produced when you burn methane completely in oxygen. That's the answer. And I hope that's helped you a bit. And I hope it makes sense. Anyways, I'm going to do one more example, which is a bit harder, and I'll be explaining a bit more detail in that next example. It's a different type of question. Oh, it's the same type of question, like ratio, but instead of, you'll see. Just watch the next part of the video as well. Don't click off yet. Okay, so titanium is extracted by heating titanium tetrachloride, TiCl4, with sodium. What mass of sodium is needed to react with 38 grams of titanium tetrachloride? Okay, so first thing we want to do is balance the equation. So if we have 4 chlorines on the left, as you can see, 4 chlorines, which means we need 4 chlorines on the right. Now, if we have 4 chlorines on the right, that also means we have 4 sodiums. If we have 4 sodiums on the right, we need 4 sodiums on the left. And there's 1 titanium here and 1 titanium here, so they're balanced. Now, let's look at what we can derive from the question. We've got the mass of TiCl4. We've got a periodic table, which means we can work out the mR of TiCl4. So we've got the mass, we've got the mR. That means we can work out the moles. So let's write the equation. Moles equals mass over mR. Make sure you always write the full equation, okay? So I'm writing N. Make sure you write moles because it'll be easier to understand that way. You won't forget it if you always write down the full equation. Anyways, so for TiCl4, the mass is 38, and the mR, I'm just gonna put the mR, I'm not gonna make you work out the mR. The mR is 48 plus 4, 35.5. I'm just doing it in my calculator. Is 190. And when you divide those together, you get an answer of a fifth, which is 0.2 moles. So this over here is 0.2 moles. Okay. Now, we need to work out what mass of sodium. So this over here, there's a invisible 1, remember? There's a 1:4 ratio, yeah? Can you see there's a 1:4 ratio? A 1 is here, and a 4 is here. So there's a 1:4 ratio, which means sodium will have 4 times the mole titanium chloride has. So we've got titanium tetrachloride here. The moles is 0.2. Since it's a 1:4 ratio, it's 0.2 times 4 equals 0.8. this moles of sodium. So the moles of sodium is 0.8. Now, since we have the moles, we can work out, and we can work out the MR, so we can work out the mass. If we rearrange the formula, so moles times MR equals mass, which means, I'm just going to zoom out a little bit, sorry. This means 0.8, because that's the moles, times the MR of sodium is 23. 0.8 times 23 equals 18.4 grams. And that's your answer. So 18.4 grams of sodium is needed to heat with this when you have this many moles.